Alright, welcome to this channel. In today's video, I'll be talking about C programming. So this video is just an introduction to C programming. You may be asking, why should I learn C programming? By learning C, you can be able to understand and visualize the inner working of a computer system. C programming makes you see how the computer works, the internal working of the computer system. This can include aspects like allocation and memory management, along with the architecture and the overall concepts that drive programming. So C programming exposes you to the overall concept that drives programming. As a programming language, C also allows you to write more complex and comprehensive programs. When you understand how a computer works, you can better design applications and sites to optimize user experience. It can also give an opportunity to interact with hardware. So for those that are interested in embedded systems, in robotics and all, understanding C language or C programming gives you an edge, because there you know how to interact with hardware, and also you'll be able to understand how the inner working of the computer, such as allocation and memory management, works. All right, we're talking about data type now. Data type. A data type is an attribute associated with a piece of data that tells a computer system how to interpret its value. In our everyday world, we are familiar with all kinds of data. We have music files or music data. We have images, that kind of data. We have video kind of data, like our music files are usually like .mp3 files, .mp4 are like video files, .jpeg are image files, and so on and so forth. Also in programming, we have several kinds of data, and it's good to know what kind of data you're working in at a particular time, because that tells the computer how to interpret its value, how to interpret its content. And we'll be dealing with three major kinds of data, or three data types in C. The first one is integers, or are integers rather. Integers are non-zero or non-decimal positive or negative numbers. So these are numbers generally in mathematics or normal numbers we use, but they are non-decimal. So they can be 5, it can be 10, it can be -6, -1 million, +1 trillion, whatever number you're talking about. So far it's non-decimal, it is seen as an integer. It is denoted in C programming as int in lowercase. And so we also have another data type. They are characters. We call them characters, denoted with char in C programming. Example of characters include our alphabet, e.g., H. This letter H is a character. Your black backslash or your forward slash or any other character on your keyboard is seen as a character in C programming. So your backspace is a character. Your space bar is a character. Your open and close parentheses, all the letters of the alphabet, both lowercase and uppercase, are all characters, and they're usually written in single quotes. So anytime you see a character in a letter or any symbol in single quotes, it is regarded as a character in C programming. We also have decimal numbers. We call them floating point numbers. Um, Example 3.14, 5.17, etc. So any decimal number is referred to as a float. In C programming, we also have another kind or another data type we call double. Double are also decimal numbers. I think the next table is going to give a clearer picture. We have the data types. We have character. Character has a size of 1 byte, so just 1 byte of the memory or is given to character data type. Integer takes 4 bytes, float takes 4 bytes, double takes 8 bytes. Double is also a decimal number. It's used to store decimal numbers, but it has a space of about 64 bits, unlike float that is 32 bits, and this is more precise. It gives a more precise value. Now these are format specifier. This just tells us, okay, the kind of data that is coming inside, as coming into the compiler or the system as an input, or printed out as an output. If it is a character, it's going to be percentage %c. If it is an integer, it's going to be percentage D for decimal. Decimal numbers are numbers in base 10, and you use percentage F for floating point numbers, percentage LF for double. Now variables are containers for storing data values. So in this example, we have a container or a variable um, named age. So age is a container where the value 15 is stored inside, and we know that it's of data type int, so it's an integer. Of course, no, 15 is an integer, so it's of data type int. The name is age, the name of the container, the name of the variable is age, and the content, the value 15, is stored inside age. So that's why you see in MC programming we declare it this way, saying int, which is the name of the data type, age, which is the name of the variable, is equal to the value, which is 15. And of course, you have to note that every statement in C is ended with a semicolon. So this is just a very um, standard way of initializing and declaring a variable in C programming. Now there are some rules in naming variable. In naming variables, number one, a variable name must start with a letter or an underscore character. So you can see this variable name age, it started with a letter small a, or at best you use, if you don't want to use a letter, you use an underscore. You can't begin a variable name with a digit, and that's why you can see the second one says a variable name cannot start with a digit. A variable name can only contain alphanumeric characters and underscore. So you can have A to Z lowercase, A to Z uppercase, 0 to 9 and underscore. Now, of course, 0 to 9 will never start the name of a variable because it cannot start with a digit. But you can mix it and put age underscore 2, and that will be the name of the variable. So these are the alphanumeric characters that you can use in naming a variable. Now, another thing is variable names are case sensitive. Here I declared it as age, or I defined this variable as age. Age in lowercase is different from age this way with the first letters in uppercase, or age all in uppercase. These are all different containers, all different variables. So these three variables are different. There is no limit on the length of the variable name. So your variable name can be as long as possible, but it is better to make it as short as possible and more precise to what it's doing. For example, here age is 15. That's very clear. There's no ambiguity in that. Age is 15. It doesn't make sense to make it very long, and it doesn't really relate to the value. No, it's good your variable name relates with the value that you are placing in it. Now, a variable name cannot contain space. Now, you cannot say, for example, this variable my age. You cannot do my space age. No, you have to join it together either with an underscore like this, my underscore age, or using the camel case. This is called camel case, where you use the first word is written in lowercase, then the first letter of the second word is written in uppercase and remaining in lowercase. So you can see this is my age. There must not be space, so it cannot contain space. And lastly, the variable name cannot be any C keyword. There are some keywords, there are some reserved words in C programming that we call them C keywords. The designers of the C programming language have used them already as keywords. So you cannot use those same words as your variable name. For example, if, for, while, etc. You cannot use these words as variable names because they are already reserved. They are already C reserved keywords. All right. So now comments. Comments are statements that are not executed by the compiler. They are used to explain code and to make it more readable. They are not executed by the compiler. They are just to make your work more readable and for you to understand, or someone else that looks into your work to understand what you are trying to do, your program. Now we have two types. We have the single line comment. This one starts with two forward slashes, single line. So it's written only on a single line. You cannot, for every new line you want to write comment, you must put this double slash. Um, the other one is multi-line comment. It starts with a slash and asterisk, just like this, slash and asterisk, and ends with asterisk rather, and slash. So that's asterisk and slash, and can be anywhere in your program. So here it's like a block of comment, a block of comments where you write so many things. You could write the author's name, you could write the function of the project. You just put information that makes you understand what you are doing, and it explains the code and makes it more readable. All right, we have something we call the Betty comment style. Betty comment style. There's nothing too special about it aside that it's always a multi-line comment. So you can see it's like the multi-line comment that we discussed before. In Betty comment style, you have to declare what the main function does. You have to give a description of your code and also the return value. So this is just the way to write the Betty style. You can see we have the slash asterisk, then another asterisk on every line, even the lines where you don't have it, you put asterisk asterisk. And so just look at this format and know that this is how the Betty comment style looks. All right. Now, compilation process. This is very important because um, whenever we write our code is the source code. It's always a .c file. When we write our program, whatever we write as our code is usually a .c file. Our goal is to compile this code or to take this code from just a source code to an executable file that will perform the task we need it to perform. So to take it from this source code to the executable file, it goes through four stages, four compilation processes. The first one is the preprocessor. Now, the preprocessor just helps to remove the comment you've written, all those things are not really necessarily needed in the program. The preprocessor takes care of that. It also helps to include headers. As you see in this course, as we progress, you see we'll start working with headers. So the preprocessor helps to include the headers, to take away comments, and the file extension. You can see our source code is usually in a .c file, but preprocessor are usually .i files. So when you take that file is sent to the compiler. Now the compiler works on the file. Of course, computer doesn't really understand your source code. It doesn't understand human readable code. What it understands is just zero and one. That's binary. So the next step after um the next step is the compiler. The compiler converts the source code that is human readable to something called an assembly code. Assembly code usually have, if they usually have file extension .s. So the assembly code is now sent to the next stage, which is the assembler. Now what the assembler does is it converts this assembly code into an object code. This object code is now the binary code that can be executed by the computer. So the assembler takes that assembly code and convert it into an object code. The object code extension is usually .o. And the last thing is the linker. Now this object code that has been created alongside some other libraries. There are some other functions or codes that have been written by either the programmer, or even that came with the C, that have been written by the designers of C program that you have decided to use as a user. There are some functions that have been written. As you progress, you understand these things clearer. You understand what libraries are. So those libraries that come with C program, or the ones that you've written by yourself, you link them. The linker does the linking. It takes the object code and it takes those libraries and links them together. And after it does that, it produces the executable file that we want. All right. So quickly, to explain all these things, let's take an example. An example says write a C program that prints the string hello, I am a C programmer. All right. So this example, in doing this, we'll just open up our terminal. could be your web terminal or any terminal. Here I am using the Vagrant Ubuntu terminal. It's a Linux terminal also, and I want to create a C program that prints hello. I am a programmer. I am a C programmer. I would like that file or the code to be written in a file that is in a folder or directory, and directory should be C program. So I'll make a directory where I'll save all my C programs. So I'll just call it C underscore programs. All right, so all my programs, all my C files I'll be writing, I'll be saving it in this directory, and I would like to navigate into this directory C programs. All right, so I change directory to C programs, and now I am in C programs. So the next thing I would like to do is to create the file where I'll write my C program or my C code, and I would like to name the file hello.c. All right, so hello.c tells us that okay, this is a C source code, and so I use my vi text editor to write the program. So hello.c, so it creates this file hello.c, and opens the text editor. All right, here in my text editor, I go into my insert mode by pressing I. I've already written the code before now, so I just copy and paste, and I will explain what's going on here. So I just copy this and paste this. All right, this is my uh, C program. Okay, let me just format it very well. All right, so this is my C program. Let me do more of the formatting. Normally, if I type this afresh, I won't need all this, but let me just correct this before I go on with this video. All right, make everything look sensible, and I will explain what all these lines of code means, and we'll probably write a fresh one. Okay, just to make this neat and readable. All right, so and this finally I have this. All right, now what is happening here? This um part under, that's the int main void and everything in this open and close parentheses. This is where your program starts running. So if I run this program, it starts from this int main function, and it goes inside this open curly bracket and checks all the lines of code inside before it exits out of the main program. All these we have inside this that are in blue color or in this block here are called comments. These are the comments I talked about before, and here we're using the Betty style. So the Betty style, we have the main telling us it prints the string in the printf function, yes, and the description using the main function. The program prints hello world, I am a C programmer, and it returns 0. So this is just the comment, and this is the header file. You may not really understand what this is doing now, but just understand that this file is what helps us to print this. The goal of this project is to print hello world, I am a C programmer, and so this is standard input output library. It helps us to take in an input or to print out an output, so it must be included in this program. As we go on in this course, you really understand what it does, but this is the major thing I want us to understand. This is the command, or should I say a function, that prints whatever you put in it out on the console. So here we have printf. Printf is the name of that command. For now, we call it command. It's actually a function that was designed by the designers of C programming language that helps you to print something out. But before you can use this function, you have to include this input output library. Since you are printing something out, you have to include it. For now, you just have to just accept that. As you proceed, you will understand better. So this program prints this string. Now, what do we call a string? A string is like a collection of characters. This H is a character, E is a character, L is a character, L is a character, O is a character, space is a character. I've said this before. So when you bring them together to form words, we call it string in programming. In C program, we call them string. So it's to print this string, and strings are usually written in double quotes. So everything you have within this open and close double quotes is a string. So it prints hello world, I am a C programmer. And of course, this returns nothing, returns zero. As you progress in this course, you understand what all this means. So this is just an example of a C program, and we've written a C program named hello.c. The next thing we'd like to do is to run this program. So I just press escape and colon WQ to see, okay, in lowercase WQ to save and exit. So we're back here. We would like to check to compile this program. So compiling this program, the C compiler is the GCC compiler. So GCC, we just use GCC. What file are we compiling? We're trying to compile hello.c. So once you press enter, it's going to go through the four processes, the compilation processes. It's going to convert it to object code. It's going to link and do everything, and it prints and it executes the file. So now the file has created. If you list the content, you can see we have hello.c and we have a.out. This a.out is an executable file. So this is the executable file of hello.c. If you want to run this to see the outcome of hello.c, all you need to just do is to execute this file is just to press to type in dot slash. Now you put in the file, the executable file a.out. So if I press enter now, it's going to print hello world, I am a C programmer. And that's what we want to do. So it's running the program now. Hello world, I am a C programmer. There's another thing I would like us to see. We would like to see if the code we wrote was Betty compliant, to see if it was Betty compliant. So you use the command Betty, and you name the name of the file hello.c. And when you press enter, you can see there was no error. So it tells us that it was Betty compliant. Remember, let's open the file again. This is the Betty style of or the Betty comment style. So to get more examples, you check the link in the description below. I have so many other examples. You just click on the link, it takes you to other examples and their answers. So you can see this is another task, and this is the answer. We have other tasks here in the answer. So just click on the link in the description below, and you have access to all these tasks and their answers. Yeah, so thank you for watching this video. Kindly subscribe to this channel, click on the bell notification to be notified whenever a new video is dropped. Click on the like button and share with your friends. Thank you.